into something that I can take into that square root. Let's think about it for a second. Let's think about that x. What do you think?
X squared? Multiplied by x.
But if I do x squared, I have to change those to x squared.
Yeah.
Right? Is that a problem? That would be 0 and 0. That would be undefined. So I can't just arbitrarily change to x squared, but you're on the right track.
1/2.
2 over 2 is still 1.
Multiply x over x.
X over x, y, I did 1 over x, I did that. So x squared down here, we can't have an x squared. I need this to still be a value of x. Make it a value of x. X squared's a great idea. X squared times x squared is x to the 4th, that's too much.
I mean, x. Root of x.
Say what now?
Root of x times root of x.
Root of x times root of x is still x. You're close. Oh, you're so close. You're so close. Put that together. You want something that equals x, true? How do you make this equal x?
Root of x squared.
Do that. And they are equal. Is that equal? Okay. No, but almost. That's our idea though. I'm going to fix this in a second. So here's the plan. Well, I know that I need this. Do you see why I need that? That is still, well, pretty much x, almost x. And that's going to allow me to take that into that square root. Do you follow me? That's important. But the question is x equal to the square root of x squared? And the answer is no, not really. Because if you think about it, why don't you take like a negative number, -5. Is -5 equal to the square root of -5 squared? No, it's not. Because as soon as you square it, it becomes positive, right? So this is not necessarily true. What is true is this. That's true. So if we have to have this, there's something that's wrong in our problem right now. This is right. What is wrong?
Absolute value.
Do you see it? You don't see it. Let me go through the process one more time. You knew, maybe if I draw in purple, it'll make more sense. You knew if you had to do that, right? But you knew that this wouldn't work. So to try to make it equivalent, you did this. That would go into the square root. However, this fails now because this is not equal. That's not equal. Notice you're trying to divide everything by the same thing, right? The same thing. So if you have divided by the same thing, these are not the same thing. This is the same thing. That's true. This is true. Yes, this is not true. Not necessarily true. So are the absolute value important? This is almost true. Is this true? Well, no. Almost. This is true. You ready to keep going? Did you understand that idea right now? You sure? Okay, so when we take the square root of x squared, we can't just have x, you have to have the absolute value of x. And I'll show you why it's important in maybe 10 minutes. For right now, let's continue working on this problem. When you have a square root over square root, that says you can take a square root of the whole entire fraction. That's x squared over x squared plus 2 over x squared. Are you okay on where the x squared over x squared and 2 over x squared are coming from? That's the sole reason why you did that, right? Just to make that in there. Over 3x over absolute value of x minus 6 over the absolute value of x. Well, that's a limit. X goes to positive infinity. You're going to have the square root of 1 plus 2 over x squared. Okay. Now we got to deal with that. I need your minds to think back to what it means to be an absolute value.
Positive values of that?
Absolute value is actually a piecewise function. The piecewise function says If x is positive, you leave it alone. If x is negative, you change the sign. Does that make sense to you? If x is positive, you leave it alone. If x is negative, you change the sign. And that was the whole idea. That's the piecewise definition of absolute value. Do you remember that? I think we did in here, actually. Well, this is how you apply that. We are going to have the 3x over minus 6 over. Now you get to change your absolute value of x depending on where you are going. Whether you're going to positive infinity or negative infinity. Where are we going? To positive numbers or negative numbers? We're going to positive numbers say that absolute value of x equals x. Positive numbers say that absolute value of x equals x. Are you with me on this? Absolute value of x, now you don't need the absolute value. You just know that since I'm going to positive numbers, that can become the x. It might seem trivial, like, well, if it's just going to change to x anyway, why do we need the absolute value? Trust me, you need them. I'll show you why in a couple minutes, okay? Now in like 5 minutes. Raise your hand if you feel okay with that so far. You see, now that we have that, those x's do match up. Those x's are gone. You get a limit to positive infinity. 1 plus 2 over x squared, all over 3 minus 6 over x. Tell me some nice things that happen since x is going to positive infinity. Tell me what happens. Where's this go?
0. 1.
Not 0.
1.
This, the 1.
Oh, 1.
The 1 goes to 1. It's constant. Do constants go anywhere? No. Where's this go? Where's the fraction go?
0.
Have we lost it all? OMG, you're scaring me, people. You're scaring me here.
Undefined.
Limits of constants are constants. Limits of this is not undefined. Where's x going? X is going to infinity. Where's this fraction going? 0. A constant over infinity is 0. Divide a constant by infinity. How much are you going to get?
0.
0. Think about that. Come on. Where's 3 going?
Nowhere.
3. Okay. Where's this going? 0. Don't forget what we did last time. This says you're going to do 1 plus 0 over 3 minus 0. Tell me my final answer, please. What is that?
1/3.
Are you okay on getting a 0 and a 0? I think we talked about that last time. A constant over any power of x as x approaches infinity is going to be 0. Because this number is getting huge, and this number is getting huge, and those numbers are staying the same. That means you're going to have a number over huge. A number over huge is 0. 1/3. Not the square root of 1. Okay, 1/3. Show of hands, how many people feel okay with that? Now, I want you to consider this. Why this is important. Think about it. You can change your problem if you want to. I'm not going to do the whole example over again. I'm not going to give you 2 examples. I'm going to show you with this. Let's say that is now negative. That means that's negative. Is this still possible? Absolutely. Is this still true? Absolutely. Is that still okay? Yes. Now, at this point, something different would happen. At this point, from here to here. You see, if we're going to negative infinity, that means that for our absolute value of x, where are we going? We're not going here anymore. We're not dealing with positive numbers, we're dealing with negative numbers. That means instead of absolute value of x equaling x, absolute value of x would equal negative x. That means that this and that would be there. Do you see the change? This would be okay. Squared, right? Squared's going to be positive no matter what. That's where our definition came from. But this would be different. What's 3x over negative x? Minus 6 over negative, well, that's a plus. That's not really going to affect us because that's being plus 0. But this definitely affects us, doesn't it? That's negative 3 plus 0. That's negative 1/3, not positive 1/3. What that says is, this is interesting. The first time we've had this, because if you've been thinking about it, you might have said, well, why do we even take positive infinity and negative infinity? Why don't we just do 1 infinity and consider it a horizontal asymptote the whole way? Well, it doesn't work. Look at that. Our first example was positive infinity, right? That's that way. That was at a horizontal, remember what these are? A horizontal asymptote? That's a horizontal asymptote at 1/3. If you go to the left, negative infinity, is it at 1/3? No, it's at negative 1/3. So our horizontal asymptotes can be different as you go to positive infinity and negative infinity. That proves it. That's different right there. How many people understood that? Cool. This row, you guys all right with that? All right. Hopefully that made sense to you. We're going to do one more example, maybe two, just to start it off. Let's try that. Show you something kind of cool, interesting that you can do. So we give it a try? Looks awesome to me. I don't know about you. Looks awesome to me. Let's try. Ready? What's infinity to the 4th power? Infinity. Okay, cool. Plus 2? And the square root of that. And then minus, so infinity, how much is infinity squared? 0. All right, done. I love that. Woo! Easy problems. Yeah? No. Fortunately, maybe coincidentally, but I really doubt it. We can't do that. You can't just plug in infinities. Whenever you get a case where you're like infinity minus infinity, or infinity over infinity, something like that, you know something bad's happening, all right? Yeah, you're not doing something right. So you can't ever do that. You get infinity over infinity, please, for heaven's sakes, don't put 1. Because that would have been 1, right? We can't do that. Well, what we do have to do is manipulate the problem somehow. Now, in this case, you have a root. You have a root minus something. What's one thing we like to do with roots minus something when we can't work on them any other way? We usually try to rationalize somehow, right? Now, this doesn't have a denominator, so make one. Put it over what? Put it over 1. Get yourself a denominator. Then you're going to try to rationalize. Conjugate. Very good. Conjugate, if you want to be fancy about it. Is it plus 2 or minus 2 there, by the way?
Plus 2.
Good. So this sign doesn't change. This sign does change. And it's over exactly the same thing. Are you okay with that so far? Yes, no? Well, the denominator has nothing to distribute, which is really nice. We don't have to do any work up there. The numerator, just distribute it carefully. You know with conjugates, your middle term should be bye-bye, right? Your middle term should be gone. We know also that conjugate works this way because the square root times the square root gives you the radicand. That's inside. That's nice. So our limit to positive infinity becomes something over the square root of x to the 4th plus 2 plus x squared. The numerator becomes, oh, what's the numerator become? Distribute, right? Do you see that on your distribution? Because you should have those. X to the 4th plus 2. We're going to have plus and minus the same exact thing.